Good evening, everybody, and welcome to tonight's edition of the Triangle Area SQL Server User Group's Advanced DBA meeting. Tonight, we have the pleasure of Karen Lopez talking to us about blockchain for the database administrator and data professional. So please, take it away.
Hi, thanks, Kevin. I'm so excited you guys are all joining us today. I first started giving this presentation, I don't know, time's so weird right now, but a couple of years ago when I noticed that Oracle had introduced what they call blockchain tables in their database. And I thought, that's the weirdest thing ever. Blockchain's all hype. Why would you want that in your database? And then I started seeing how organizations were using blockchain-like features in their database. So that's led to where we are now, as well as the fact that blockchain features are now in Azure SQL DB and SQL Server. Okay. Hold on. Now all of a sudden, okay. There we go. Sorry for that little user error. So I've been doing this data stuff for like 20 plus years, and it's actually closer to 30, but I stopped counting at 20. I do normally talk about data quality, data governance, data modeling, data-driven methods, as well as Azure data platform things. So do you know why this is it stopping, Kevin? Sorry.
No, you're live. You're gone. Everything is looking good.
Sorry, it's there's something like I'm getting a blurry screen now.
No, you're nice and clear on this side.
Okay, don't know what that's doing. Okay, so I'll try to stay away from the keyboard. So actually, I'm an MVP in data platform. I tweet a lot. So if you follow me, just know I tweet a lot, like hundreds of thousands of times I've tweeted. I'm also on Facebook and LinkedIn. If you want to friend me, follow me, or link with me, I appreciate if you put in the little comment thing, hey, we met at this meeting, and I'll process it faster. I'm also a certified Azure data engineer, and fun fact, I just renewed that certification today, so it's fresh and new. I am a Datanaut, which means a NASA Datanaut, which means I volunteer to help mentor people working with NASA open data. I'm also a VMware expert. So for this session, there's some theory, there's some DB specific stuff. Hopefully my demos will work. We'll talk about use cases and myths about blockchain. Please ask your questions as you think of them. Don't hold them till the end. I'm going to get interrupted if there are questions, and I'm perfectly happy with that. Sometimes the questions get down on a sidebar or too far down a technical thing, and that's okay too. We'll just move on. The other thing you need to know is I am not going to have enough time to cover the nuance of everything about these technologies, but my goal here tonight is to make it interesting enough or intriguing or confusing enough that you'll want to go learn more. And mostly at the end of this, I want to make you look good when you're in a meeting and blockchain or ledger tables comes up. You'll know what you need to know in order to respond. So like I said, I started giving this when Oracle introduced blockchain tables in their database, and I had my doubts about whether that was needed because I felt that blockchain was just a bunch of buzzwords and could never be of interest unless you wanted Bitcoin or you wanted to get wealthy. And then I realized there was more and more focus on data uses, and I want you to have a better understanding of why you might use a full-blown blockchain solution or why you might want to use ledger tables in the Azure and SQL Server world. I do own a blockchain dress. I'm not wearing it. Today's nerd dress with pockets is the patent application for Hedy Lamarr, yes, that Hollywood starlet, who invented networking and communication like patents that has led to us having Wi-Fi and internet. Why is this important to you? Well, you should understand the concepts of blockchain so that you can better make recommendations on your teams or to your clients. You should also understand business implementations that are used in enterprises for blockchain and what are the database technologies. And since this is a Microsoft related group, we're going to focus primarily on the Microsoft technology. So normally I would ask in person who you are because I'd want to know who I'm talking to. But because I can't see you and we don't have that feature, I'm going to speak today as if most of you are DBAs, data architects, and developers. And if you're not one of those people, that's okay. This presentation should be accessible to you as well. And then I would normally ask, have you used blockchain personally? Have you used it in your professional life? And have any of you gotten rich from Bitcoin? And the reason Bitcoin comes up in this topic is because blockchain itself was developed in order to make Bitcoin work. But that doesn't mean that blockchain has to involve Bitcoins at all. And when I say Bitcoin here, I really mean any cryptocurrencies that are out there. I know there are dozens and dozens now. But the reason I didn't capitalize Bitcoin there is I really just mean cryptocurrencies. And yes, that's the pattern from my blockchain dress. So I'm going to go through the non-fluff, lower hype definition of blockchain basics. And as I talk about these basics, there's a million more pieces of details that are available about these things. I mostly just want to talk through some of the terminology we typically hear when we speak of blockchain. So I said that it was originally developed by an anonymous person who goes by the name, I believe, of Satoshi. It may be a person, it may be a group. It was originally developed for Bitcoin. It has lots of buzz out there. There are lots of new words and terms. There's lots of hate for it. So every time I pitch this to a group that is really anti-hype, like some data people, I get lots of hate back for it. No, our users don't care about Bitcoin. No, it's not about Bitcoin. It's about blockchain. Or that's just going to be a flash in the pan. Nobody uses it. I don't know why they added it in there. So we're going to deal with some of those things. Now, these headlines that I've snipped out of these screenshots, like, look at them. They go back to 2016, which really does feel like a lifetime ago. But we started hearing about, most people associate blockchain with Bitcoin and therefore assume that all uses of blockchain are nefarious, malicious, all the other bad words, in that because that's what it was developed for, anonymous payments and selling and the dark web, that somehow blockchain itself inherits those bad traits, and it's not true. So some fundamentals. And if you look at these, they sound a lot like regular database things. So for instance, all the transactions in blockchains are time-stamped. And by time-stamped, I don't mean the old Microsoft misuse of that term. I literally mean tracked with a date and time. And yeah, a lot of our transactions are too. But these, when I use the word transactions most of the time tonight, I don't mean database transactions. I mean something, it's close to that, but I mean something that's more like how we use business transaction. It's an event that happens that gets a whole bunch of detail recorded about it. That's what I mean. The other important thing with blockchain is this concept of immutability cannot be changed. So blockchain was originally created, and we'll see how this happened, so that data could be recorded and nobody could tamper with it. So the way I think of ledger tables in SQL Server is when you need to ensure that data hasn't been tampered with. And we'll talk about how we used to do that in the past, how it would be done in ledger tables. The other thing that's a feature of traditional blockchain is that the data itself, the data that's in a block in a chain, is distributed across many nodes. But these nodes aren't like in Azure Synapse or Hadoop, where one person owns all these compute nodes and one person has access to that. One entity, let's say, manages them. In the blockchain, one of the features to ensure that data couldn't be tampered with is that the transactions would be distributed across multiple nodes that are owned by all kinds of people or all kinds of entities. Therefore, in order to tamper with the data, not only would you have to break into a system, you would have to break into systems that are owned by a diverse set of people. And we'll see a little bit more about that in a couple of slides. Each node in a blockchain is chained to others through the blocks. We'll see a thing about that. And everything has a hash, a cryptographic hash that is used to do the chain. So I said here, transactions, I'm quoting someone. It's basically the same thing as a database transaction, but since we're database people in this meeting, I want to say it's a bit different than like turning transactions on, running a query, and then applying the transaction or rolling it back. But it does have that similar nature in that it has a start and a stop. That's about the only thing it has in common with a database transaction. So this means, much like in generally accepted accounting principles, or GARP, that a transaction cannot be changed. What it means is that once the data is written, it's always there. And in order to change the data, you have to record a new transaction that replaces the old one. So if you put in the blockchain that my name is Karen Lopez and I decide that my new name is going to be Kitty, you don't go in and update Karen to become Kitty, is you record a new transaction that says that my name is now Kitty. That's how it works. So it gets offset with another transaction. Now, the other interesting thing about these nodes is much like in distributed database systems or file or storage systems, there's this concept of consensus. So a transaction, one of the things you need to realize is if you had, let's just say, 100 nodes in your blockchain, we know it takes time to write to 100 nodes. There are trade-offs here. There are nodes might be down, nodes might be full or throw an error of some type. When you write these transactions to the blockchain, once 51% of the nodes in that blockchain have reported, I have successfully recorded this transaction, that transaction can be considered as completed and recorded that way. And there's a whole lot of nuances that happen right within that one bullet point there. But the gist is it's based on consensus of the nodes. And if you remember, unlike a traditional distributed system that you might manage, these nodes are owned by different people. They're controlled by different organizations. And therefore, the fact that 51% of them recorded the transaction and agree upon it is good enough. Again, not the same as distributed systems you manage because you have control over all of them, but similar. But eventually, the transaction gets recorded in all the nodes. Each of the nodes is referred to as a distributed ledger. And it's not just enough to get one or two, you have to get 51%. The node architectures are based on that P2P type principle of, that some other software systems are based. There's no centralized owner or manager because that would break the trust in the nodes, and it's consensus based. So let's look at a very high level example of a block in a chain. So you have this one transaction of data that has the data about the transaction. So that's block number one. And it's got this hash one with the data. And this is not the format of the data. This is just a graphic. it is chained to the next block of data. And you see that number one? That's number one is the hash of all of this data. And then the hash of all this data becomes hash one. And then it's chained to the next block. And then the hash of this data in the block becomes number two. And then it's changed to the last one, number three. If there were more in the block, then that three would be in the next block. So this is why it's called blockchain. We have blocks of data that are chained together, and the cryptographic hashes are the things that chain it together. So if I were able to break into all the systems at exactly the same time and change the data in this block, what would I do? Now the hash would be changed, and therefore it wouldn't point to this block anymore, and that means the chain would be broken. That's the sort of logic behind it all at a very conceptual layer. Of course, as we're going to see in a few slides, it's much more than just breaking the data. It is the fact that there are certain technologies, both software and hardware, that are used to protect all of this from being tampered with.
We have a question from chat.
Sure.
Could you explain the chaining together a little bit more, like what you mean by how they're chained?
Okay. I'll try to give this, and we might see this later too. But so let's say this data says that my name is Karen Lopez. So that data, Karen Lopez, is hashed, like encrypted and hashed. Oops, sorry. And that means that, let's say the encrypted hash of Karen Lopez is KL, even though it wouldn't work out that simply. But let's say the hash is KL. So this particular block has KL in it. And because it's the head of the block, that's all the hash it has, is the hash of its own data. Now we're going to write in that my cat, Hanson Lopez, is the second block of data, right? So Hanson Lopez's hash is HL. But in order to chain this block to the first block, the hash from this block goes right here. So that would say KL, and this would say HL. But these are cryptographic hashes, right? And then my other cat, Armstrong, his data, his hash would be HL for or AL for Armstrong Lopez, but his block would be chained to Hanson's block by bringing that hash over here. So it should remind you of relationships in a relational database, but it's not that at all. It's hashes of the data. Does that answer your question, maybe?
We'll find out in a moment.
Yeah. That's fine. You can always interrupt me again. So if you're going to add a block to the blockchain, you're basically telling the chain, hey, here's a transaction of data. It's a block. We're going to send the transaction to all the nodes in this distributed, multiply owned nodes. Then the nodes are going to validate that transaction. And once you get consensus from 51% of the nodes, then it's considered complete. And that block, that transaction's worth of data, is added to the chain. And eventually all the nodes get the data, but you just need 51% to say yes. So that's a very high level conceptual process. Now, so we said we're going to have multiply distributed data. It's going to be based on cryptographic hashes. There's going to be immutability to increase trust. So the reason for blockchain is to increase trust, or another word for this would be confidence that the data has not been tampered with. So if you were a bad person and you wanted to go in and secretly manipulate the data, you would need to change it all eventually. But at least 51% of the data which are managed by different people and different locations, might use different technologies and everything. Plus, you'd have to have those systems believe that it all happened at the same time with the timestamp. So that's the trust part of it. The other feature of, and remember now, we're not talking about ledger tables or anything in SQL Server. These are the basics of blockchain terminology. So the other interesting thing about blockchains that we typically don't do with our enterprise database systems is that the chains are typically public and open to the public so that everyone can see the chain and the transactions and the timestamps. And you can also follow the history of that data, because remember, you can't update data in blockchain. You create a new transaction to offset it, or to supersede it, maybe is a better term. And the way you might have heard of this before is that, so if we jump over to Bitcoin, because that's a common usage of blockchain, is that people will say, okay, someone just sold $100 million worth of Karen coin. That'd be a horrible name for a coin, but of Karen coin. And the reason people know is they watch the blockchain to see this transaction. Now, the transactions themselves, one of the features of Bitcoin, not blockchain, is it's all anonymous, right? So you have a Bitcoin wallet where you keep your currency, and you get to do all these transactions that aren't directly linked to you. They're linked to a wallet where you keep Bitcoin, and people can see when these things change. Now, you're probably not going to put all your retail point of sale transactions in your enterprise system in a public area where people can see all the transactions. So there's also sort of a fit with public blockchains and traditional blockchains, is it's really good for data that isn't sensitive about people. Although there are ways of doing that, of course, with encryption and everything. So the other thing to remember, I'm quoting Jerry Weinberg here in Secrets of Consulting, where he says, trust everyone, but always cut the deck. One of the reasons why people think that blockchain is so hyped and so wrong and just worthless is that blockchain doesn't validate the truthfulness of the data. It validates whether the data has been tampered with. So we can have, Karen, I'm up here either carrying a pineapple or a bag of money that I stole, and I can tell the blockchain that I put $4,000 into your account, right? I can tell the blockchain that. And the blockchain would be perfectly happy to say, yes, Karen put $4,000 into your account. But that's because blockchain's only job is to prove that I didn't put 4 cents in there and then change it to 4,000. So lots of people write these big expose articles and blog posts about how they inserted fake information in a blockchain, and the blockchain was perfectly happy to accept it. And you know what? They're right. And the blockchain did all it was supposed to do. So if you put in a blockchain transaction that you gave me 4 million Bitcoin, and by the way, please do that you gave me 4 billion Bitcoin, the blockchain's just going to agree. Yeah, if you somehow get that into the chain, the only thing the blockchain's going to prove is that no one changed that 4 million from 4. That's all it does. So a lot of the people, there is a lot of hype about blockchain and Bitcoin. Like I attended a conference maybe 3 years ago where someone assured me that all banks, all media companies, Netflix, all companies were going to go out of business because everything would be done via blockchain and there would be no way to stop it. So yeah, that might happen someday, but blockchain isn't going to solve all things. So the other feature of blockchains is this concept of triggers. And this is the number one reason why regular old businesses have been quick to implement this technology. So the most common use case that I saw early on for enterprises adopting blockchain was in that logistics space. So the thing about like retailers and distributors and shippers and transport, one of the problems that they dealt with making payments is everything constantly had to be audited, and that to see if anyone had changed anything. And the other thing about logistics is, from a parts to a manufacturer to a distributor to a retailer to their warehouse to a shipper, that all involves a whole bunch of different parties and different people. And if you could cut the time between an activity happening and payment being made for it, the whole process would go faster and be cheaper. So we're going to talk about this a little bit more, but what's built into traditional blockchain systems is this concept of when the shipment arrives, once the data has been verified that it hasn't been tampered with, then payments can go. And this is totally oversimplifying this business case, but understand that blockchain has allowed companies to save time and money in dealing with complex business transactions. Okay, that was the introduction of some of the terminology and also to traditional blockchain. Now, when we talk about blockchain and databases, some of those things go away on purpose, but it becomes a trade-off. So let's talk about how traditionally a ledger works. And by a ledger, I mean like a chart of accounts or your books or your inventory. Is traditionally every organization had their own ledger and they managed it, managed by one entity. But in order to ensure the data hadn't been tampered, is we had to have auditing processes that would, maybe sample some transactions. And by transactions here, I mean business transaction. Let's say a payment was made to a vendor. So they might go in and verify with the vendor that the payment actually made it to them. Another thing an auditor might do is see what are the controls in your system that help you, that build confidence that people just weren't out of the blue able to go in and update their payroll or the price of an item. So auditors are typically used in traditional accounting systems, whether it's inventory or money that you're accounting for, in order to build confidence that the data in the systems were trustable, right? That you could trust that data. It also requires a lot of reconciliation for when errors are found or things were updated incorrectly. Many times we found that systems weren't as secure as we thought, and they might have encryption on them. Hopefully most of them do, but they might not. In blockchain, we trade that auditing and reconciliation by implementing all the blockchain features that boost the confidence that we have that we can trust the data. So multiple copies managed by multiple entities, transparent, trustable, and encrypted. So that's the theory, the difference between a traditional system of accounting and auditing with blockchain. Okay. So now we're going to talk about ledger tables in Azure SQL DB. These are also in public preview in SQL Server, by the way. There are two types of tables that you can make in SQL DB and SQL Server. One is an append-only table. So much like what we just talked about in traditional blockchain. So what we have is you have your SQL database and you have a table that you create just like any other tables, but you say ledger is on, it's a ledger table, and that it's append only. And by append only, it means you can't update it. If you try to update a column in a row, it's going to say, hey, you're not allowed to do that. But if you wanted to introduce a new row for the same person or the same product or whatever it was, or the same account, you would insert a new row and it would be newer. So you would take that as the current view of that person or that product. There are also ledger views that you can do to see all the extra information that SQL Server adds to these things that make it a ledger table, and we'll see some of those things. Now, within your database system, you have this concept of the blocks. You just the chaining and the blocks will be hidden from you because you want all the queries to go against the table to look like it was just another table. So it looks like a table. It looks like a table where no updates are allowed, but you can keep adding rows and adding rows to it. The other thing is the actual database ledger that keeps track of all this, plus the time set, plus the hashes and everything, should be stored in trusted storage. And that means that not only do we have this table, but we have think of it like a transaction log, but not the same as the SQL Server T log, but a log of all the transactions that happened against that table are stored away from the database in either Azure Storage or Azure Confidential Storage. And that means that anyone who was able to log into SQL Server and change the hex on the underlying file because they had super duper access and they were able to clean up, it doesn't change what's in that transaction log. That means that when someone goes to verify the ledger, it's not going to verify. So verifying a ledger is an important piece of blockchain. And what that does is it compares what SQL Server thinks is in this table to a copy of all the transactions in a blockchain form and will point out if some change were to happen. This is usually where I get questions. Are there questions in there?
There are a few questions. Some of these are kind of stemming from the intro section.
Okay.
And one of them was if there are max data sizes per block or per data element in a block.
So if you're asking about generic blockchain, I don't have an answer to that question because it was just the basics. If you're asking about in SQL Server, it will have all the same limitations that SQL Server has for table sizes and things like that.
All right. And is it possible to manipulate the data in a way that you could force a collision?
A collision of what? The hashes?
Yeah, the hashes.
Okay, I'm not an always or never person, but I think because these are cryptographic hashes, the only time, how do I want to say this? I think just the size of the cryptography, it's a really good question. I really want the answer to be no, it wouldn't happen because of the way hashes work. But that's a good question that I don't have an answer to.
Fair enough. And I would be interested in getting a better idea. I think I'll have an answer to this later on, so I'll temper that question right now. But getting a feeling for what makes the trusted storage actually trusted and prevents somebody from modifying the actual blocks themselves.
Mm-hmm. So I'm going to go ahead and answer that because it's timely here. So the simple answer is you would never give the same identity access to both SQL Server and the trusted storage. That's the very simple answer. The better answer is that normally you would build this on Azure Confidential Storage. So Azure Confidential Storage is something I could do a whole 1 hour on. Storage is that it's a confidential storage is a special, or confidential computing as well, is a combination of special hardware, software, and secure enclaves, to use that term that you might have heard about in SQL Server, secure enclaves, that all comes together that really makes it hard to get even access to this trusted storage. I mean, it's not just storage, and it's not just trusted because you like to trust it, but because it's based on confidential computing, which is a whole specialized area of keeping people out of even getting to it, let alone tampering it. And it often is based on immutable storage, so storage itself where the data can't be changed except through the process. So I want to also step back a little bit. Let's talk about what we did up until this feature was available in SQL Server to make sure data wasn't tampered with. Well, we used regular permissions, right? Let's only give this application, this firewall, this port, these IP addresses, these MAC addresses, these logins. Like that's traditional security for a SQL Server, and role-based security and server-based security and all of that stuff. But what we ended up with always is there was always a super admin or an admin who, by definition, had access to everything, mostly to just bail us out of doing something really wrong. So we always had that problem. So we also had other technologies that we could use. We could copy the data to another table that kept like a ledger to it, but then that super admin might have access to that. We could use change data control, so it was writing a log somewhere of all the things. We used to roll our own update processes, often based on triggers, that every time data was updated, copies of the before and after were someplace else. So that's how we've dealt with this up until now. And we still will have a lot of tables where that's good enough. But this particular feature is designed for where none of that is good enough. And the real difference within SQL Server is going to be for there to be a really strong wall between the SQL Server parts and the trusted storage. I hope that begins to answer your question there. So then one of the things that's different between Oracle's implementation of blockchain tables and SQL Server's version of ledger tables is SQL Server has delivered an updatable table into their ledger tables. But having said that, it just acts like an updatable table. It's not actually updating the individual blocks. So the blocks themselves are still append only. So what's different between what we saw in the previous slide and this one is that if you create a table in SQL Server, say it's a ledger table, and say that it's updatable, then SQL Server all on its own will create a history table, and it will do all the same things, trusted storage, all this other stuff. But this system created history table will allow you to see all and query all the, Karen and Lopez, and then Kitty Lopez, and then I get tired of being Kitty, so I go back to Karen. But in the updatable ledger table, you'll just see my current name. So it really is, while it is called and acts like any other table, you can update any column, any of those things. It's really just presenting that as if this is still a table, but as if this was a view of the history table, if that makes sense to people. But everything else is the same. Now, when you create a ledger table, you say at that time, so when you create a table, you can create a regular table and you can create a ledger table. And at the time you create it, you get to choose whether it's append only or updatable. And of course, the way you choose is what do you need. So let's say I have a ledger table that just logs, every time a door opens in your facility, like what badge was scanned, what was it? Probably you don't want that as an updatable table because you're logging events. And once the event happens, it's happened. And if the wrong badge got scanned or something like that, you still wouldn't want to update it because it's acting like a log or a audit trail or something. But if your ledger table were just people, employees in your company, and you wanted to make it highly tamper proof, then you might want it to act like an updatable table because, of course, information about people changes all the time. So let's talk about some key features in ledger tables. So in addition to making a ledger table, you can make a ledger database. And when you create a ledger database, that means that every table in it is going to be a ledger table, and every table created in the future in that database is going to be a ledger table. And once you deem a database as a ledger database, it can't be changed. So a lot of the things that we're going to be talking about have a and it can't be changed, with a few exceptions that I have some slides for. Then there are the database digests, which are literally those like record of everything that happened. You can make the tables, they can be updatable or append only, we've talked about. Immutable storage stores outside your database in a Azure storage account or something else, if it's SQL Server, where you manage the immutability and you don't want to give the same people IDs or logins access to both places. And if it's truly immutable storage, even someone who had access to it wouldn't physically be able to change that data. And then you have this function, or in the case of SQL Server, a stored procedure that you can run that verifies that the data in your table and the data in the digest is still in sync, which is a verification that the data hasn't been manipulated with. So here's the typical schema that you might, or the creation statement that you might see about an Azure ledger table that is append only. So you see we have the regular create schema, the regular create table, some columns. And by the way, in SQL Server, you should not call your tables timestamp because timestamp meant something else. But in the real world, that's a timestamp. Anyway, and that you see there's a with clause where you say ledger on. That's how you tell it it's a ledger table, and append only is on. Look at that. It's just like any other create table. And of course, this is a very simple example. And then if you want to create an updatable table, same thing. Create the table, create your columns, and you say with system versioning on, that's your keyword for it's now going to be an updatable table, and ledger is on, which makes it a ledger table. Make sense? I hope so. So let's see, give me a second to move things over.
While you're doing that, yes, it makes sense.
I was hoping. Okay.
There's a question while you're getting that loaded.
Okay.
Is Azure Storage required to use ledger tables or databases?
So it is for Azure SQL DB, and I wanted to say a preference here. I've only used this in Azure SQL DB, and I know it's in public preview in SQL Server on-prem or on your laptop, depending on what you're doing, but I haven't looked at a lot of those features on the on-prem side yet. So this will be more of the inspiration for you guys to go find out. Is that fair? Just say yes. Okay. So we have this, oh, you can see I tried to drop it. So we have that same create table statement for append only. Yeah. Oh, yeah, sorry, I was supposed to. Boy, am I out of practice for doing demos. Okay, so I've created the table. I've probably lost. There we go. And you can see this new table. and it just looks in SSMS like any other table, because that's what it is. And this particular database I'm working in is in Azure. That's probably why we're having a little bit of this stuff. But you can see here that after I created the table, those are the 3 columns I created, but it also added start transaction ID and start sequence ID. So I've been loose with my terminology so far, but you add rows to the table, but if you add 3 rows, like if we do an insert, that's considered one ledger transaction. So again, we're not talking like I don't have, okay, here we go. Oh, I only have 1 row in here. So I can, what do you mean? I just created it.
Wrong database?
Oh, yeah, sorry. I do this all the time in with my Azure things, because you can't use a use statement in Azure SQL DB. Thank you. Newbie move. So I've added some rows to it, and it's added these extra columns for you. Look that they're big ants, which just makes it a little bit bigger. And then same thing. So you can see there's my 1 row. I've got the timestamp, and this was the ledger start transaction ID. If I had inserted 3 rows, they all would have had the same transaction ID. It has a start sequence number. It was the first one, so of course it starts with 0, because that's how computers do counting, right? Any questions about those?
Slightly unrelated, well, mostly related. With
Okay.
Ledger on is pretty easy, but is there additional config or setup required ahead of time, like specifying where that log might be stored?
Oh, yeah. So, yeah. So because this is in Azure, there's a whole lot of things that you create when you create an Azure. So maybe let me get through this part, and then if my portal's still open, we can pop over to the portal and look at those. Okay. So this is a similar, this is an updatable table. So I can have an account balance, and I've just said that it's updatable. And so I can insert a row. Oh, God. Oh, you guys are going to hate me. I can insert a row. Now I can insert 3 more. Then I can go look. And you can see I have my customer IDs, last name, first name, their balance. See how that was the first row I put in, then the 3 I put in together got the same transaction ID. And then it also had the sequence so that I know what order they would put in. And then because this is an updatable table, I can update it, and we changed the balance. And now Nick, who started out with 50, now has 100. All makes sense. Now there's a whole bunch of other stuff that's going on underneath all this, because there are the system versioning table, the history table behind all this, and the history table. Let me do a refresh. I think Azure, the internet is slow in Canada. It probably has customs and immigration slowing it down. Well, anyway, so you can see that, oh, that was the droplet. Here is the history table for The only updatable table I have, which I happen to know, is account balance. And you can see that all of these other objects got created in your database, but that when I created key card events, so this is I had created it earlier and dropped it. So you were supposed to ignore that. But all of these things are happening in your database, and it can get confusing. Imagine if you had a full ledger database that had 200 tables and that most of them were updatable. You're going to have these history tables. And in order to find the history, you're going to have to query the two tables, but you're going to have to go find the object IDs for them. So the reason I'm leaving this all up is, of course, this demo pulls from the Azure SQL DB, the Microsoft Docs on ledger tables. So you can pick up from here and go follow the rest of those things where you validate it against storage and all of those things. So let me see if my of course it's expired. So this is my server where my database is. But I could go back into the server and create a database. If you've ever created one in Azure before, I'm in a subscription in a resource group already because that's where the server is. I can create a database, no elastic pool. I'm going to go ahead and do that. Say local redundant because it's just a demo. I could add my own address, like all this stuff is the basic stuff. Here's my little commercial for setting up Microsoft Defender for SQL. If you have access to that, it's only, this says 19 because I'm Canadian. It's $15 per server per month. You guys should all be running that. And here's where you configure the ledger. So I can either create the ledger as create this as a ledger database. I'm not going to right now, but this is where if you choose that, then all future tables would be part of that. And then I can create the digest that I want, and I get to choose between regular Azure storage, which means much more shared responsibility on my part to secure that, or I can choose Azure Confidential Ledger, and if I had any created, I would do that. Right now, because everything's in preview, I can't type crap. Then I could go set up all of this confidential ledger because it's in preview. Look, it's free in the standard tier, but I'm not going to go ahead and create this database, but that just shows how you can either choose plain old Azure storage and create your own with your own containers. And then lots of advice on how to lock it down better. I'd say go with the confidential ledger because now you got hardware and special secure enclaves to protect it, and that's less work you have to do. Any other questions come up?
Yeah. So can the schema of ledger tables be altered? Like, could you add, drop columns, change names or data types?
Good question. The answer is sometimes yes, sometimes no, but I have a slide on that coming up.
Excellent.
So for that. And
the other question's about performance, but I figure you probably have something coming up on that as well.
Yeah, and of course my answer is going to be it depends. So if you had gone through all, like I did show the, that Nick started with 50 and ended up with 100. And then if I had queried the history table, you would have seen some of the operations that happened against it. Like what really happened under the covers was not an update. it was a delete and a logical delete and insert. It didn't really get updated. And then one of the most important things is this database digest verification. And that's basically, there's this procedure in the demo thing, and you run this stored procedure so that it says, yes, your ledger, the ledger digest that's in storage matches what's in your database and vice versa, so that that's your signal that nobody has tampered with the data. So some of the restrictions, because that also is a thing, some blockers. So the reason I put this update and merging rows, this is actually a very similar list to what Oracle has, except up until now, Oracle does not have updatable tables, nor can you rename things, nor can you make any changes. So they have built their blockchain tables to be much more like traditional blockchain. They want it to be used for really locked down scenarios. So you can't, once you create a ledger database, not a table, a ledger database, you can't disable the ledgerness of it. Like once a ledger database, always a ledger database. You can't rename tables. You can't change column formats, like going from time to number to anything, but there's a little star there because they allow non-destructive changes. So if you had unfortunately set the length of email address to be varchar 25 and you realized your mistake and decided to match the internet standard of varchar 254 or 255, you can do that because it would be a non-destructive type change. So in SQL Server, you can change column formats. Then there are certain data types that aren't allowed. We see those a lot. You can't do this for in-memory tables. You can't truncate an append-only table or the history of an updatable table. But you can truncate an updatable table, but not the history table. A ledger table can be converted to a normal table, but not the other way. A transaction a single database transaction, a SQL Server transaction, can update up to 200 tables at a time. And it also inherits all the restrictions on temporal tables, if you're familiar with those. So that answered the question. And there might be other things that you can change and everything, but the amount of things you can change is much less than a plain old table because it's intended to not tamper with the data. The reason you'd want to use a blockchain or ledger table is that you can trust that data more because it just has all these extra protections, some of them based in hardware, not and immutable storage. This will offer more protection from DBA or high privilege sysadmin tampering. And one of the things I wanted to point out to you, I use smart designs in PowerPoint all the time for my slides. And every time I put DBA, it always chooses the skeleton man. I have no idea why, but I always keep it because I think that's funny. You would probably want to use ledger tables when you don't need or don't want the full-on blockchain functionality. Now, one of the things I wanted to point out is that if I were a DBA and sysadmin and I wanted plausible deniability for not having tampered with the data, I'd be a huge fan of ledger tables because, like, yeah, I don't have the skills or the access to tamper with the data. So it's funny. I've learned over the years that the less production data I personally have access to, the better I feel about not being able to be accused of something. DBA should be a huge fan of ledger tables because it protects them from being accused of having messed with the data, or at least it adds more protection. So one of the benefits of blockchain, now we're back to blockchain, not just ledger tables, but we were able to squish some business processes to make shorter processing change at times because we're able to trust the data. It can have lower costs to businesses that way. It can have fewer certain risks. And you also get to say, yeah, I work in blockchain all day. So I'm going to address quickly some of the fluff around blockchain. I hear this all the time. Blockchain is about Bitcoin and hiding illegal acts. We know that's not true because big name companies, people who do logistics, finance, everything, are investing heavily in blockchain and blockchain technologies in their own companies. Like they're actually spending shareholder value on implementing it. And then this was, blockchain. Traditional blockchain is free. So it's going to put out every business that charges small fees. I don't know about you. I still pay credit card merchant fees. I still have a bank. There are still music labels, but that's changing for all kinds of reasons. Amazon's still in business. Stock exchanges are still in business. So I don't know how you feel about that. So in real life, blockchain is used a lot in supply chain, logistics, inventory, transportation, healthcare, utilities, and financial. I'd love to hear about any other unique industries that are investing in it and using it and deploying it, in case anyone knows of any. Besides NFTs, I don't need to know about NFTs. I don't want to know about NFTs. So there was a large global Canadian retailer, and this data is really old, so I need to go update it. But they had significant cost savings by adding this to their supply chain system, and everyone got paid faster as well. Some old stats from 2019, $3 billion spent implementing blockchain. That increased almost 90% from the year before. And look, now we're in 2022. I need to go find out if the prediction, if this was still on. Some of the fun things about blockchain. So you may have heard of Bitcoin miners or cryptocurrency miners. What cryptocurrency, the way you make money mining for cryptocurrency is there's a lot of compute needed to do hashes and to do the consensus of all the things. So you can earn cryptocurrency by supporting cryptocurrency. And in 2017, the world used more energy doing Bitcoin mining than the whole country of New Zealand. And in 2010, an early Bitcoin user bought 2 pizzas for 10,000 Bitcoin. And in August of 2021 was the last time I checked the price of Bitcoin. But those 2 pizzas, those 2 pizzas cost him the equivalent of $457 million if he had just kept his Bitcoin. So that's why I always ask, go see if you have some old Bitcoin wallets that you signed up for. What does this mean if you're a database designer or a data modeler or an architect? If you use any third-party tools with SQL Server, you're going to want to check to see if those tools support these new objects or these new parameters. This is always true with all databases these days. I don't know how third-party tool vendors keep up with all the changes since they're happening much more often. Microsoft officially has the cloud-first approach, so they tend to put new features in Azure SQL DB, and then once they get the telemetry and figure out how it's being used or if it's worth investing in, then they'll put it into the SQL Server on-prem product. I think it's important that we be advocates for ledger tables to say, hey, I know you're thinking of implementing change data control or our traditional ways of making sure this data isn't tampered with. Maybe we should consider using a ledger table or a ledger database instead. And then because people have this sort of overhead and baggage in their heads about Bitcoin, about Bitcoin and blockchain, you need to be able to explain the differences from full-blown blockchain to ledger tables. the last thing I wanted to put in to remind people, if you want to go play with this, is for 12 months, you can get for free. So there's a free 30-day subscription to Azure that usually comes in around 150 or 200 bucks US. I haven't kept track, but it's all dependent on your local currency. But there are also free tools that are always free in Azure. And these are targeted for people who just want to learn more and play with it. This is a tiny number of the services that are included, but you can see right there, you can get 12 months of Azure SQL database, of a tiny little thing with 10 database transaction units. That's just a way of paying for hardware, software, and networking and data and stuff. I always encourage people to, even if you have a work account where you're allowed to use Azure, but using only it for production things, that you can always sign up for a free account on Azure if you want to go play with stuff, but your company doesn't want to fund it, or if you have no access to Azure at all. There's even Cosmos DB. There's like dozens of services, storage, and everything that you can get for free. And now I'm asking, are there any other questions, discussions, heckles, quotes, rants and raves about blockchain or Bitcoin or Azure SQL DB?
We have a little bit of all of those. So let me head up here a little bit. There was a question about the Clr data types, things like hierarchy ID, geometry, geography. It looks like there's nothing in the docs that says they're disallowed, but those usually go with like XML and file stream and the other, the weird stuff we're not going to deal with.
Yeah. Boy, it's funny bringing up hierarchy ID. So that's a cool one. So the thing is, remember that last line on incompatibilities or blockers was and anything restricted in temporal tables. So you have to look both in the ledger table docs and the temporal table docs to get the full list.
Fair enough.
And my list on a slide might not have copied everything too. It's just to give you a feel for it.
Oh yeah. While you were going through there, I looked at the docs itself, and it doesn't have CLR specified either way either.
Okay.
So, triggers and foreign keys would be allowed on ledger tables.
For sure, foreign keys. Like it acts like any other table. I just try to avoid triggers, so I don't have that answer.
How about computed columns?
Was that in the list?
I don't remember seeing it in the list.
I don't remember, but like for those kinds of questions, first of all, you always have to go look at Microsoft Docs to get the current answer for sure, because sometimes Microsoft and all vendors will roll out something new, something that's in public preview, and it has unsupported things just because they haven't supported it yet. And then sometimes the not supported things are there because it's obvious they're never going to support it. So the typical things that aren't supported, say in Azure DB, are things that have to do at the lowest level physical infrastructure, like setting your own file systems and everything for Azure SQL DB. They're just not going to allow that because you don't have access to the disk when you have Azure SQL DB. And then other things, they eventually get added. They just have released it early in order to get the feedback on it, and then they'll get to those things later.
Oh, okay. So we're getting more questions about performance. And
So that's a good question because, again, I'm not a DBA and I always forget that one. I don't have like a big scalability performance thing. All I know is that, it works like many other tables. I would think that, like, I'm always going to say that performance is, this is like the same question for me of should we encrypt a column, right? I mean, these days, a lot of times you don't have a choice whether you're going to encrypt data because it's required by legislation or because it's required for policy. Performance is an important question, even to me, but I think if you need ledger tables, you're going to fix performance in some other way than not using ledger tables. Just like with encryption.
Okay.
I know that's not a DBA answer.
Yeah, Mala's guess was it probably has about the same performance impact as temporal tables.
That was my guess, because I think it's based, that's why they say it. I think it's kind of underlying based that way a little bit.
Yeah, and there might be some additional impact just from the actual hashing, but depending on how that works, it may not be significant.
Mm-hmm. And hashing is usually done. I mean, is done in the compute part. So it all has a big. It depends for on-prem, of course.
Right. Okay. Since forward hashes with strong cryptographic security and encryption and Merkle tables are all available without blockchain and without proof of work distributed consensus, if you don't have a dispersed trust model, why would you use the blockchain concept to begin with?
Okay. So there's a whole bunch in there, and it says blockchain concept, but are we talking about ledger tables actually? Because there's a whole bunch of reasons to use traditional, like the full-blown blockchain thing. And that's why there is public blockchain, like that the crypto coins are based on. There is, you could set up your own private blockchain that doesn't have multi-owner, but has all the other stuff. You can, I mean, Azure has blockchain services, software vendors have private blockchain services. I mean, it's all a big, it depends on what your business case is. So it's my guess that private blockchains are used because the business case doesn't require that sort of extra trust of having multiple owners and node consensus and all of that stuff. Like it really is a what do you need and how are you going to solve that need type answer, which I realize is an architect, a consultant's big, it depends, but I believe this. Like you wouldn't go say, okay, I got Karen coin and I'm going to implement it in my own Azure SQL DB because I can use ledger tables, because no one's going to trust Karen and her single Azure database that she totally controls and could shut off, which we've had happen with other coins. But the ledger table answer is because you just need more confidence in the non-tampering of your data, but you don't need the extra confidence that a public blockchain brings you. And maybe in 5 years, we'll all be laughing about how confident we were in blockchain because someone's figured out how to hack it with an iPhone and a Raspberry Pi.
So then the follow-up question there was, why then have private blockchains?
I mean, because so every design decision is based on cost, benefit, and risk. So if you're going, a private blockchain might just have might just have some of the features like immutable storage and separation of the digest from the table. Like, I'm sorry, I keep coming back to it depends. Not every security question needs blockchain, and not every adoption of a subset of blockchain features is bad. I see ledger tables as inheriting the features of blockchain in a way that I can trust more than the traditional ways we used to try to keep sysadmins and DBAs from messing with the data. And even developers, because everyone gives developers sysadmin rights, right?
No comment.
My developers tell me that all the time, that they've always had sysadmin access to production.
Somebody responds in chat, private blockchain is like decaffeinated coffee.
And it still has a little bit of caffeine and can keep you awake if nothing else is available. I think part of this question, what's embedded in it, is there. I'm really talking. I gave basics of blockchain, or I mentioned Bitcoin and stuff like that. But I think that there are blockchain thinking and blockchain technologies, but blockchain with a capital B is a whole system of things. It's not just tech, it's not just hardware, it's processes, it's standardized, it's those things. And really today's thing was more about the technology behind it and how relational database vendors, like I cut out my Oracle stuff from this presentation, but it's basically the same concepts with a little bit more features right now on the Microsoft side that are in the Oracle side. And I think that will always be changing, but it's adopting some blockchain fundamentals and thinking inside SQL Server, but it won't serve the needs of someone who needs the full-blown, transparent, anonymous blockchain. Again, another big it depends.
All right. So I think that looks like it's all of the questions that we have.
Excellent. Those were great questions. And I encourage you all to go into the tutorials in Microsoft Docs and run through those things. If you have to set up a free Azure account to do that, please do that. You'll have 12 months of that. And go see if you can break it. Like there's probably a bug bounty for breaking ledger tables, I'm sure.
Maybe so. All right. Well, with that, let's see. Very nice words in chat. Very nice words.
Thank you.
And great job with the presentation. We definitely appreciate you taking the time to talk to us tonight about the topic of ledger tables.
Mm-hmm.
And with that, there are no other questions in chat. We are going to wrap up for this evening. So thank you, everybody. Thank you, Karen.
Yeah.
And we'll see you next time. Next week, hopefully. If not, next time we see you. Until then, everyone, take care.
Thanks.